Good afternoon. Welcome. My name is Justin Smith. I'm a technical evangelist with Microsoft. It's good to be here. Glad you guys are here as well. For the next few minutes, we're going to talk about workflow-enabled and durable services in the .NET Framework 3.5. I'm co-presenting this session with my good friend Matt Winkler. He's sitting up here in the front. I'll be doing the first half of this talk, and then he will come up and finish the talk. If you have any questions, comments, or personal attacks about this session, I ask you to wait until the end. We do have 2 microphones, and we will leave some time for questions. You can ask them then. If you feel that you are about to spontaneously combust, if you don't ask a question at the moment, then you may, of course, raise your hand, and I'll try to call on you. Let's go ahead and get started. But before we do, I'd like to do a really quick survey of the room. So this is really simple. Please raise your hand if you have experience with Workflow Foundation in the .NET Framework 3.0. Okay, you can put them down. Please raise your hand if you feel that you are an expert with the .NET Framework and Workflow in 3.0. We have 1 expert, 2 experts, okay? How about Windows Communication Foundation? Who has used WCF? Fantastic. Who considers themselves an expert in Windows Communication Foundation? All right, very good. So we're really going to be talking about how these 2 technology stacks from the .NET Framework 3.0 come together in the .NET Framework 3.5. So the objectives for the next few minutes or our time together is to give you a good architectural overview of how we've done that integration in .NET Framework 3.0. We also want to give you some guidance about how and when you should use implicit or explicit context management, and I'll explain more what context management means a little bit further into the presentation. And then we'll also talk about some common archetypes, if you will, or patterns that you can build into your applications that take advantage of the features offered by workflow services in the .NET Framework 3.5. I assume that if you're in this room, you are a competent .NET Framework developer. I assume that you have experience in either Windows Communication Foundation or Workflow Foundation. I also assume that you have some exposure to the other technologies. So if you've been using, in a very deep way, Workflow Foundation, I assume that you've had some exposure to WCF. This talk is really about bringing those 2 technologies together. Our agenda is fairly straightforward. We're going to do a little bit of level setting with both technology, and then we'll talk about how and why these 2 technologies are better together, why they are living together in perfect harmony. And then we'll do an architecture look at WF, how we can do workflow services, rather, how we've actually built up the stack to do the integration between WCF and WF. My good friend Matt is going to come up and show you some different ways to apply that information. So we'll see some examples of how we can do context exchange, how we can do duplex messaging, as well as some conversational bits. Okay, let's go ahead and get started. Level setting with Workflow Foundation. I won't spend a lot of time here because I realize that the audience, practically everyone raised their hand with exposure to WF. But the idea with Workflow Foundation is it's a way to organize work, or it's a way to describe some sort of application or business logic. Right, so we have a workflow runtime that is now on every Vista machine. Anywhere you install .NET Framework 3.0, there is a workflow runtime. We also ship some activities that allow you to model whatever the logic is that you want into your application. And we also make those activities extensible, so that you can create your own activities, whether they be domain-specific, something specific to finances, something specific to manufacturing or healthcare, whatever your vertical is. You can build all sorts of extensibility. There's all sorts of extensibility points for making workflow do precisely what you want it to do. Personally, I kind of have to say this because I work for Microsoft, but I personally believe, and I'm not just giving you a marketing line here, I personally believe that WF is a revolution in how you can build and model applications. If you guys have seen what we've released or announced, rather, last week with the SOA and Business Process Conference in Redmond, the idea of this kind of modeling is something we are placing a large bet on in the future with a technology called Oslo. So we are continuing this paradigm, this workflow paradigm, and really extending it dramatically over the next few years. So we've got the basis for it now. We've got a really interesting runtime engine. When this was released in the .NET Framework 3.0, November 2006 kind of time frame, we saw a large uptake of the developer community. We saw a lot of interest in this technology, and we found that people genuinely were starting to model parts of their applications using Workflow Foundation. So that's just a real quick overview of DubF. My good friend Matt is going to have quite a bit more to say about that towards as we work through the presentation. Now I want to kind of transition over to WCF. I'd like you to ask yourself, what is a service? We talk about services all the time. Service orientation is something that's probably embedded into our lives as developers or architects or IT professionals. I mean, this is something we deal with every day, but I find that not too often are we really asking ourselves, or do we have a good definition for what is a service? So if you ask yourself that kind of a question, hopefully what comes back as an answer is that a service is really some functionality that's exposed via a structured messaging scheme. The big points here, and we're talking about any kind of functionality, could be something that perhaps was modeled or built in Workflow Foundation, right? Workflow Foundation is all about building logic or functionality into an application, and we can expose that kind of functionality as a service, right? So we've got some functionality that's exposed via a structured messaging scheme. This definition, I hope, will last for quite a while. Others have their definitions of a service. This is just mine. You can take it or leave it. But I try to keep the transport discussion, the format discussion, the encoding discussion totally out of this definition. Because when we think of web services, what pops in my mind, at least, I don't know if it does yours, is something like SOAP or some sort of XML, some variant of XML, and something happening over the HTTP transport. It can be actually quite a bit more than that. You can have messages that are encoded or formatted as a JSON payload, JavaScript object notation. It can be just plain binary data, some sort of opaque binary data. It can be plain old XML. It can be SOAP. It can be any number of things. So when we consider how we build services, we need to think in terms of this broad definition of a service. Right, so when we think about the different variations of services, we have to think of what are the message exchange patterns or the MEPs that we build into our services. A datagram is a one-way message send. There's also request reply. We're very used to that on the web. We do a request for a web page, we get something back. There's also duplex, which is similar to a phone conversation where both parties can communicate at will after the communication channel is established. There's also many formats that are in use today in the web service world. SOAP, we all know what SOAP is. Probably if you're in this room, I hope you know what SOAP is. JSON, it's one that has gained popularity at a geometric rate over the past 5 years. Right? JavaScript object notation, it's huge for AJAX applications and platforms like Silverlight. Plain old XML, that's just an XML bit that's going across the wire, and you can insert lots of others at will. Transports, there's all kinds of transports that we need to use when we're building services. HTTP is clearly the most pervasive ones, probably the first one that you think about, but we cannot exclude the other transports that are possible for services. There's a couple of architectural styles that have gained prevalence in service development as well. The two big ones are WS star and REST. Everyone know what REST is? R-E-S-T, a couple people. Well, there's several talks this week on REST. We have in WCF support for both of these architectural styles, and I assert that it's first-class support. So when we talk about building services, services is in the title of this presentation. When we talk about building services, you have to think in this broad set of terms. There are all these different flavors of services that are possible. In Windows Communication Foundation, I assert, is the Swiss Army chainsaw of service platforms. This is one stack that can cover that entire gamut of flavor, or that entire spectrum of service variations. It gives you complete flexibility of your message exchange patterns, your formats, your transports, and of course, your protocols. And what's really cool about WCF, it gives you a unified programming model that spans all of those flavors. So the developer experience for a web service that's using HTTP is going to be very similar to the developer experience when you're using MSMQ. I also assert that WCF is the gold standard across the industry for interoperability. There tends to be a rumor or tends to be some myth that we at Microsoft don't give a darn about interoperability. That is completely false. I don't know where it's coming from, but that's not true. We absolutely care about interoperability. We have teams of people that test interoperability. Interoperability in WCF comes in two forms. It comes in the embrace of WS star, that set of standards and specifications. It also comes in the form of our first-class support for representational architectural styles, or REST. Right, so WCF can do that, and we think it also has great manageability features like tracing, message logging, WMI integration, configurability, denial of service remediation controls, threading capabilities, instance management. Could go on and on and on, but it's got that stuff just built into the platform. This was introduced in .NET Framework 3.0, and it was enhanced in the .NET Framework 3.5. Now, a couple of bits about WCF, and the reason we're drilling into WCF a little bit more than WF is some understanding of how a WCF application works is important in understanding how we've brought them together, WF and WCF together, in .NET Framework 3.5. So there's a couple of important constructs in WCF. The first is a binding. Now, you can walk up to the SDK, or you can walk up to some examples with WCF and just start using it. We've tried to make it very approachable, but WCF internally has a very interesting architecture. It's a deeply layered architecture, and a binding is one of the first places you start to see that deep layering in the architecture. Someone walks up to you on the street and asks you, I will give you €1,000,000 if you can tell me what a binding is. I assert that most people that are using WCF would not be able to give a correct answer. A binding does one thing and one thing only. A binding creates a collection of binding element objects. That's all it does. It does nothing else. The trick is a binding element object collection turns around and creates some other stuff. And that other stuff starts to do the work of messaging in an application. For example, a binding element object can create either a channel factory or a channel listener. Channel factories are for sending applications. Channel listeners are for receiving applications. That begat the question, what does a channel factory do? What does a channel listener do? A channel factory creates a sending channel stack. A channel listener listens for incoming messages and creates a listening channel stack. That begets the question, well, what does a channel stack do? A channel stack either sends or receives or otherwise mangles a message. So we've really got 3 to 4 layers of indirection in that stack, and it's all started with your choice in binding. So if somebody walks up to you on the street now and asks, what does a binding do? Hopefully you have a good answer. But a binding is not where it starts and ends with WCF. We need to combine the messaging characteristics of our application, that is the binding, with a couple other bits. We need to combine it with an address. An address is clearly where we're going to be listening for a message or where we're trying to send a message. And we have to couple that with some description of what our messages are actually going to be. That's a contract. So we combine an address, a binding, and a contract into an endpoint. An endpoint is a source or a sink of a message. Right? We define contracts through annotated type definitions. So we create a type definition. It can be either an interface or a class, and we add some custom attributes to it, thereby changing the metadata of that type when it's compiled. Meaning at runtime, we reflect over that type definition to build the proper runtime. So if we have a service contract like the one that's up on the screen, it's public interface my interface, it has one interface, or it has one method, and it has a void return type and accepts a string. We need to take that interface and implement it in a type definition like the one down here that says service type, and that can be a type that the WCF runtime instantiates. So our gross anatomy at a really high level is simple. We just create addresses, bindings, and contracts into endpoints. We build a service contract, and we add a type that implements that contract, and it seems to be really a piece of cake. What's going on behind the scenes is actually quite a bit more complex. I'll dive into it a bit more in a second. But this is the high-level picture of WCF. I actually wrote a book about what's going on in just this simple slide. Right? So this is, in my mind, a quite interesting stack. And here's kind of what it looks like at runtime. So up at the top left-hand side of the screen, we see we've got a service.cs file. Imagine in your mind's eye, if you will, that C# file has a type in it that is going to be your service contract and also going to be your service type, as per the previous slide. We then add some config to that, and we shove that into an object whose type is service host. It's a .NET Framework 3.0 type. The service host will create another object graph that is called a service description. The service description is actually a blueprint for how the service runtime is going to work and also the channel stacks that it will create. So the service host creates a service description. The service description is used to create a service runtime. That service runtime is just about the topmost part of the WCF stack. We have a listening channel stack that's right below the service runtime that will pull messages off the wire in our receiving application. So that is a pull model. We then put those messages into a queue, and then we pump them into the service runtime at a rate that is determined by a couple of knobs in the service runtime. So that's configurable. Once we dispatch a message into the service runtime, we will then invoke a method on a service instance. The type that that service instance is referring to on the loader heap is defined by what's in our service.cs file and how we've configured the application. So we're going to invoke, ultimately, a couple of instance methods on that service instance, and that's just strictly going to be dictated by how our service runtime is built. That's how the WCF stack works in a nutshell. Okay? So this is kind of the basics of what's going on at runtime. It's my assertion you need to kind of grok this slide if you want to really grasp what's going on with the dubf WCF integration that we're talking about in this presentation. Given that runtime, given the capabilities that you guys have already seen in the .NET Framework 3.0, we got some feedback from customers after .NET 3 was released. Among that feedback was questions like, hey, we'll build this service, but how do we have a durable persistence layer beneath the service? So what happens if I have a service that needs to communicate with the same clients over a long period of time? However you define a long period of time. Could be a couple of minutes, could be a couple of days, could be months, doesn't matter. How do I have a durable backing store to help me keep track of the state of a particular instance of a service? It's a very good question. Another question that came up quite a bit and bit of feedback that we got was, I've got these workflows that I've built. How do I take that functionality and expose it as a service? In other words, how do I make the entry point for this service some receipt of a message? And how do I do that with the same flexibility that you get in WCF? In other words, how can I accept a message off of MSMQ? How can I retrieve that message and start a workflow with it? And how can I participate in that workflow through a series of other service calls? Likewise, how can I do that if I'm receiving a message over name pipes? Or how can I receive a message off of TCP/IP? I think you get the idea. We got an overwhelming bit of feedback about that, right? Now, given that dubf and WCF were in the same stack, .NET Framework 3.0, we found that another subset of customers was going ahead and integrating the two on their own. So big ISVs, some small ISVs had just undertaken this work on their own because they saw the power of having these two stacks, and they said, we'll go ahead and integrate them. So here's a couple things you would have to do if you were to try to do this integration yourself. First, you'd have to figure out how to start the workflow runtime. So you'd need to figure out, how can I receive a message, or how can I spin up the workflow runtime from the same process that's hosting my services? How do I create an instance of a workflow? And then how about, after I've got an instance of a workflow, how do I map received messages to that particular workflow instance? Right? Also, if the workflow instance that relates to a received message is already there, but maybe it's dehydrated, maybe it's stored somewhere, how do I rehydrate that workflow instance easily? Right? How do I enter and exit a workflow at the right time? There's lots of threading concerns there. Right? You've got really different threading models in WCF and WF, and making sure that integration point makes sense is actually not trivial. Right? So these are just some of the things you'd have to undertake if you're building the integration yourself using only .NET Framework 3.0. So we sat down in a room and said, I wonder if we could do this ourselves to really help the development community and say, you know what, we'll take care of the infrastructure for you, and everyone can have that same integration, right? So one of the motivating factors here is we know that infrastructure code, or this type of integration where you're doing these kind of complex operations, is prone to problems. It's actually, infrastructure code is probably the most expensive code that you can write because it takes your most senior developers. Furthermore, it's the most expensive code to test because you have to test for such a wide variety of situations. Not only is it the most expensive code to test, it's also the most expensive code to maintain, because if you have a problem, probably it's going to be a transient problem. If you have a problem with threading, you're going to have to get into all sorts of creative debugging situations. So we said, we'll lower the bar for doing this kind of integration and do it ourselves. And what's really interesting about this, we used all .NET Framework 3.0 extensibility points to do this integration, which is interesting in a couple of ways. When you see a new technology from Microsoft, my assumption is that you're probably a little skeptical. When we say this is our platform for the future, when we say this is a platform that will last you X number of years, you probably are a little bit skeptical because we release an awful lot of technology. Certainly in the past few years, we've released a lot. And one of the things that has typically been a barrier to a stack living a long period of time has been, ooh, gosh, something else appeared in our industry where we now need to go off and start doing this other stuff. JSON is a great example. If you were in the web services community in 1999, 2001, 2002, JSON probably was not on your radar screen. It probably wasn't something that you were thinking about as a messaging format. More than likely, SOAP and plain old XML were. If you're really out on the edge, then maybe REST, but certainly not something like JSON. However, you look at a stack that's as layered as WF and WCF, we've been able to adapt to things that are radically different, like SOAP, in the same technology stack. And kind of a validation of our architecture that helps us feel that this stuff is going to last for a while is the fact that we've done these kinds of integrations. We have enhanced the stack, right, for things like JSON, Silver, or this integration, excuse me, with just our extensibility points. We haven't had to reinvent the wheel. We haven't had to reinvent the architecture. Sorry to go off on a tangent. I hope you will forgive me. Here's the workflow services architecture. Same slide we saw before as our WCF stack, but here are the extensibility points. The first thing we did is we built a workflow service host. This has the same base types as the service host type does in WCF, but it automatically adds some behaviors to the service behavior collection. Right? So it actually creates a different service description. Notice in the service description box as well, we have a couple of new behaviors. We have a workflow service behavior and a workflow operation behavior. This helps us set up the appropriate service runtime, right? And that's kind of in the middle of the slide. So we have a workflow operation invoker. The purpose of that workflow operation invoker is to ensure that we invoke the right point in our workflow. Because remember now, we're not really building service instances and invoking methods on those. We're really invoking activities that are in a workflow. Right? So that's the idea with workflow services. Instead of invoking a type, we're invoking a workflow, which, if you look at it, right, is still just an object. Okay? We've got a durable instance provider. Matt will talk more about that a little bit later. And at the bottom of that service runtime slide, you see a message context inspector. Now imagine in your mind's eye a little bit about what it took to do this integration. We could have lots of workflow instances running at one time. Each workflow instance, since you guys have used workflow before, will have some sort of identifier, some sort of GUID, or some sort of key that you can use to map to that identifier. So the way we map messages to a particular workflow instance is we take that instance ID and we simply shove it into messages that we're sending out of the workflow. And when we receive a message, we hope to see that GUID in the message so that our service runtime and our listening stack can map it to the appropriate workflow instance. There's a couple of ways that we shove this information into a message. The first way we shove it into a message is as a SOAP header block. Right? So we simply add another header block to the message. We can also use a cookie, an HTTP cookie. Right? So we can actually change the state of the client to include a cookie. Now that's the instance identifier. That's the instance identifier we use to route the message to the appropriate workflow. It's kind of interesting that once you're in the WCF stack, it all gets shoved into a system.servicemodel.channels.message object anyway. Internally, our message object is the abstraction of a SOAP message. So that's just a core construct in WCF, so we pretty much have to shove everything into that object through the runtime. Just a little interesting tidbit there. Now notice on the right-hand side of the slide, we've got our workflow instance and we've got our workflow runtime. And instead of dispatching to a method, we're dispatching to a receive activity. As we can with any workflow application, you can persist the states of that workflow instance into a persistence database as per all the rules that were instituted in .NET Framework 3.0. Make sense? Very good. We did this through a couple of new types. I'd mentioned a few of them on that slide. There's a couple of WF activities. There's only two activities that changed in 3.5, or that are new in 3.5. There's a send and a receive activity that are really the sending or receiving of a WCF message. Right, so when we use the send activity, we're using WCF to actually send a message. When we receive a message, we're using WCF to receive a message. So those are two things that will appear in your toolbox, and they're just designed to work with WCF. Remember at the beginning of this talk, I mentioned the role that bindings play in the WCF runtime. Well, to add message headers, a SOAP header block, or a cookie to a message, we need to change the bindings that we're using. So if we want to change a message, the way we do that in WCF, in the most abstracted way, is with a new binding. So we have some new bindings in .NET Framework 3.5. It's the basic HTTP context binding, the net TCP context binding, and the WS HTTP context binding. As you can tell from their names, they are very, very similar to the bindings that we introduced in .NET Framework 3.0. The only thing that's different in these bindings, remember what a binding does? The only thing a binding does, it creates a binding element object collection. So the only thing that's different in these new bindings is it adds a context binding element to its collection of binding element objects. That's the only thing it does. That's all it does. So we took the existing bindings and we just add a new binding element in the collection. That binding element, all it does is make sure that we shove the right instance identifier into a message or we pull the right instance identifier out of a message, whether it be a cookie or a header block. So we have constructor arguments that indicate whether we want to put these in a cookie or whether we want to put these into a header block. There's a couple of behaviors as well, and that helps us change the service runtime. It says how are we going to invoke these workflow instances, and how are we going to persist these instances, how are we going to create these instances. You see the names of them up there, right? These are the important ones. We also have a couple of hosting options as well. There's the workflow service host that I mentioned on the previous slide, and then there's also the workflow service host factory. The reason you would use a workflow service host factory is it makes it easier to work with the SVC file integration that we've got in .NET Framework 3.0, WCF and the .NET Framework 3.0. It's important to note, however, that this stuff does not run in partial trust. So we added partial trust support for part of the WCF stack, but the workflow runtime is not included in that set. Okay, so when you're running this on a server, you need to make sure that your application domain is running in a full trust sandbox. So just a few new types. We didn't radically change the architecture, but this gives you the ability to send and receive messages that are backed by a workflow. Okay. Given that scenario, there's a couple of approaches that you could take to this model. One, you could say, I've got some services, and I just want their backing store to be a workflow. So I've got a service, and I want to implement it as a workflow. That gives you a couple of nice features. First, it allows you to leverage this pretty development experience that's associated with workflow. As a personal note, I have a background as a graphics developer on the Unix platform. I used to work in the CAD/CAM space, computer-aided design and computer-aided manufacturing. I throw up a little bit when I think of developing with pictures. It's against my nature. But after I got used to workflow, I started to kind of like it, right? It is actually a very nice experience. It makes simple things really, really easy and lets you make some really hard stuff easy as well. Okay, so it allows you, when you implement a service as a workflow, to take advantage of that great development experience. Whether you like it or not, you can either use it or leave it to the side, doesn't matter. It also enforces, you can map out your application protocol in a workflow, and that ensures that as you're invoking a service, you're doing it in the order that the workflow wants. Kind of nice. That is a little bit harder to do. It's actually quite a bit harder to do if you're not using workflow there. It also allows you to have long-running, durable services, which is kind of cool. That means I can have a conversation that spans 30 days. I don't have to maintain the same state on my service. Pretty powerful. You can also take a workflow, you can kind of spin this model around and say, instead of having a service implemented as a workflow, maybe I've got these workflows and I need to expose them as a service, right? So I can build a service contract directly from my workflow. We've got a really interesting designer experience there and tooling experience where you can extract, if you will, a contract directly from a workflow. That gives you the ability, or it sort of enforces and makes you use serializable and by-value data in your workflow. Kind of a nice feature there as well. And it also means your workflows can be message activated. So it can be not really running, your workflow runtime will be running. When a message received, that's when your instance will appear. That's when you'll create your workflow instance. There's actually quite a bit more that we can say about this, and Matt's going to be talking about a lot of this in the first demo. So with that, I'm going to turn it over to Matt. You guys can welcome him up on stage, and I'll be back up towards the end for Q&A. Thank you.
All right. Thank you, Justin. So as Justin talked about, we've got a lot of reasons why we want to do this. Workflow provides a really natural model for us to use when we want to build a service. And so what I've done, I've got Visual Studio 2008. I've started a new project. I go to the WCF project templates, and I say I'd like to create a sequential workflow service library. It's going to go ahead and bring this up, and it already puts a receive activity on here. The send activity is very, very useful for consuming a service or for sending a message, but that's kind of boring. That's what it does. It lets me call another service, so I'm not going to spend too much time talking about that. I'd like to focus on the receive activity. If I double-click this receive activity, it brings up an operation selector dialog. And what this dialog allows me to do is to go to a contract and select the operation that I want bound to this receive activity. So when a message comes in for that operation, this is how the workflow or the WCF infrastructure is going to look at that message and deliver it to this activity. In this case, it's the first activity, so we also mark it as can create instance. This means we now know we have to spin up a new instance of the workflow. The model here, we can just follow the arrows. A message is going to come in, we're going to do some work, and then we're going to send it out. So let's go ahead and drop a code activity in here. The code activity is fantastic for demoers because you can just get it up and running pretty easy. So we'll just write something out. And we're going to say that the return value equals the input message. So these two, return value and input message, these map to the parameters, the return value and the incoming parameter on that operation. If we go back and look at our workflow and look at our properties, you'll see that the return value is mapped to that and the inbound message is also mapped to that. We'll set a breakpoint in here and go ahead and execute this. What this is going to do is spin up, in Visual Studio 2008, we've made a lot of investments in the tooling around WCF. So this is going to spin up a self-host. If you're familiar with ASP.NET development in Visual Studio 2005, how you don't need to have IIS, you can spin up that Cassini host. This is very, very similar. In addition to that, we also have a test client. This test client is going to look at the service, and it's going to allow me to, not surprisingly, test the service. So I can go ahead and send messages to my service without having to create a client, without having to create a host. This allows me to get up and running very, very quickly. So now we're going to go to that hello operation. We're going to say pass in Justin. So he just finished talking. We're going to hit invoke. That's going to deliver that message. That message is going to be the first message that we've seen. And that is going to dispatch a workflow instance. Once that gets into the workflow instance, we're going to execute that code activity and go ahead and return that value. Now, we mentioned that would be what we would refer to as the contract first approach, where I start with an interface, I start with that contract. But there's something else pretty cool that we can do here, because not everybody thinks of contracts first. And so we're going to drag another receive activity on here. Double-click this, and instead of importing a contract, which is going to reflect over all of the types contained in the assembly, we're going to add a contract. This contract allows me to define operations. I can define my types, so I'm going to return a string, or I'll return a byte, and we'll go ahead and add a parameter. I can also go ahead and select complex types here if I have other types or data contracts inside my project. I can reference those. Real quick, I want to show a couple of other options here. I can also set this to be a one-way operation if I want the one-way flag set on that operation. And I can also set permissions. And this is pretty interesting. This leverages all the stuff that's already in WCF, but it surfaces it to me, the activity, the workflow developer. And so I can take advantage of kind of traditional role-based security. So I can say that only managers are allowed to call the fire employee service. But I can also use claims-based. And what that allows me to do is get a little more dynamic with my security. So I can say that the only person who can cancel an order is the person who originally submitted the order. And so both of those aspects, the claims-based and the role-based, are surfaced as part of this activity. Final part that I want to show here is flip over and look at this as XML, because I want to show what's happening when I decide to create that contract. So we'll open this in the XML editor. And you'll see what we've done here. We've declaratively marked up this activity with the description of the contract. Now, when I hand this to the workflow service host, the workflow service host is going to look at all of the metadata of this activity, and it's going to use that to dynamically materialize this endpoint. So this is kind of cool, right? I'm not using a traditional contract that's decorated with the attributes. I'm embedding this into the workflow. So my workflow becomes the model not only of the process, but also of the data that we're going to be sending in and out. So now the next thing that we can talk about, we realize that a lot of the work that we had to do was to teach WCF how to interact with something that's long-running. In the first case, that long-running thing is just a workflow, but we realized, well, we've done all of this work, why just limit it to a workflow? Why can't we also just invoke some object that we've persisted and allowed to sit for a little while? And so we take this same infrastructure, we can add the durable service attribute to a service, and all of a sudden, a service that we write in C# code that is not a workflow can also persist its state out, so that in 30 days we can come, call that service again, hand it some context so we identify that instance, and then we're going to be able to continue to interact with that. So we're going to be able to store all of that state. So we start off like any WCF demo usually does, with a service contract for a calculator. It's truly an enterprise class application. It's going to add and subtract and multiply and divide numbers for us. We haven't done anything different here than we normally would. But now on the class where I implement that interface, I'm going to add a couple of other attributes. I'm going to add the durable service attribute, and then for each of my operations that are going to participate in that, I'm going to add this durable operation attribute. Now, with workflow, I can define my application protocol. I can say, this is the activity, this is the message that's going to activate the workflow, and then you're going to wait and receive this one, and this one, and this one, and they're going to happen in a given order. When we express a service this way, we don't have the ability to specify all of that order, but we know which ones are going to initialize it, so we can say which operation is going to create an instance, that is the power on. We mark up all the other operations that are going to participate in this. We mark those with durable operation. That just says when that comes in, I need to retrieve this object from some store, call the service, call that operation, and then when I'm done, I need to persist that back out. Now, at some point in time, that needs to stop because we're going to no longer need our calculator, or the order is going to be complete. And we want to clean those resources up. We don't want those hanging around for the rest of time. And so we can mark the operations that will complete that instance, so that when that operation completes, we're going to clean that up. So we can't have any additional interaction with that service. We'll go ahead and run this now. And we also have a very fancy WCF calculator interface for this. So our service is up and running, and we're going to go ahead and begin to use the calculator. This first service call is going to happen, and we're going to return back an instance ID, and now I can continue to use the calculator. What's interesting about this, well, there's a couple of things interesting about this. So I'm going to go ahead and close the calculator. I'm going to go to the database. We use, just like in Windows Workflow Foundation with a SQL persistence provider, here we have a SQL persistence provider for the durable services. So if I go and look at this table now, you'll see, hey, there is an instance type. Here's the instance ID. Here's some XML that describes that. And that is our service, or that is our object that we're going to be interacting with. I can also go ahead and just kill the service. So I can completely stop everything. Now let's go ahead and start this back up. So I've restarted the service. So that is up and running, and now we're going to start up the calculator again. The calculator also does a little bit of work to have on the client side. It keeps a small piece of data so it remembers that instance ID. So when that calculator comes back up, we're going to be able to continue interacting with that service and with our application. So I can go ahead and add 56 to that. So I've picked right back up where I left off. I've survived the host recycling, I've survived my client recycling, taking advantage of just storing this information off in SQL. So we've talked about really simple communication patterns. We've just talked about talking to a single activity. But in order to maintain a more interesting conversation, in order for me not to just say hello to you, but for me to pass some additional information on to you, or request additional information onto you, we have to have a little bit more information. We have to have this context, the workflow instance ID, so that I can continue talking to that instance of the workflow. Now you might say, why can't I just use something at the transport level? Why can't I just rely on the fact that it's coming over the same connection? Well, since we're talking about something that's long running, that transport level based idea of session starts to fall apart, right? Because I can't rely on a TCP connection being alive in 3 weeks when my boss approves an expense report. So we have to move that from being managed at the transport level up into the application level. And before we can do that, we need to agree on how are we going to pass this context back and forth. And the way to think about this, we're going to start with a client and a service, and we're going to assume that both of them are workflows. They don't have to be workflows, and we're going to show how we can have plain, normal code call a service and still pass context. But let's imagine that they're both workflows. The client is going to call the service, and is going to send over some parameters for whatever that operation is. Now, the workflow service host is going to look at that incoming request and say there is no context associated with this. There is no header that tells me which one this is, which workflow this should go to. I'm going to take that. That's my clue. Hey, I need to create a new instance of the workflow. So I'm going to spin up a new workflow, and when I do that, I'm going to grab that GUID, that workflow instance ID. Now that workflow is going to do some work, and eventually it's going to send a response back to the caller. This is where the context channel comes in. The context channel is going to say, I know that I created a workflow for this incoming request. I should let the caller know who the workflow is. I should let them know what that context information is. So it's going to pass back in the header, or as a cookie, if we're using HTTP, that context information. Now the client is going to receive that and say, I should probably do something with this. If I need to talk to that service again, that instance of that service, I need to attach that into the header of my message and send that off. Now the second time that our service replies, there's no need for me to attach the context to that, right? That wouldn't make any sense, because the only way somebody could have called that is to have attached the context to it. And as we said, this is kind of the simple case where a workflow is interacting with another workflow. And so the tooling is going to take care of a lot of managing of this context for us automatically. So we don't have to deal with this. But let's say, for instance, we wanted to communicate with this workflow from another application. So first we kick off an expense reporting process, but then my boss has a tool, that a Windows Forms app that he pulls up on his desk, that shows the expenses, and from that tool he says, I'm going to approve this expense report. Now we have another application that needs to talk to that workflow. The pattern that we follow here is we need to create a repository for context. We need to store that somewhere that that client can then retrieve. What will usually occur is that this gets associated in some kind of a lookup table that is a cross between, say, the order ID, and then we're going to add that workflow instance ID, so that when I go from my other application and query and say I would like to get all of the expense reports I need to approve, we can go ahead and pull down that ID as well. So the first thing our workflow is going to need to do is store off that instance ID. We have a client that is going to go to that repository, get that context ID, and now when that client wants to interact with the workflow, they're going to attach that into the header. And then the infrastructure is going to take care of that for us. Once that message gets received, we're going to look at it. We're going to say, hey, there's a context ID, and I'm going to deliver that message to the appropriate workflow instance. Talk a little bit about the architecture here. We mentioned that this is the context channel. This is the layer that takes care of this for us. And the execution semantic is important here. We only return the context once, and that is on a message that will activate a new instance of the workflow. That's going to be the only time we return that. So if we return it to the same application that's going to continue to interact, we can just use that and reuse it. If we have to have other applications interact with our process, then we're going to need to persist that off from within the process so that we can access it somewhere else. The other responsibility of the context channel is going to be to add that context to all outgoing messages. This is how, once we start a conversation, we don't have to worry about this. It's because it's going to be attached to that context channel, so it's going to keep writing that on each one of the messages that are going out. Justin alluded to what this looks like. It can be a SOAP header. It can be an HTTP cookie if we're talking over a transport that's going to support those. And then in code, it's represented as a dictionary of XML qualified name and string. And you might say that's a little funny. If it just has to be a GUID, why do I have to have a dictionary? And we'll see why that's important in a little while. So if we want to set the outgoing context explicitly, we're going to head and just the send and receive activity both expose very nicely a context property. So inside the code dealing with our activities, we can just go ahead and grab that context information. If we want to have a non-workflow client having access to this, we're just going to walk up to that proxy. We're going to grab the context manager. That's going to allow us to either get the context or set the context. Now you might say, but Matt, I live in a world where some of my clients aren't going to be using WCF. How should I deal with that? Well, since we're just writing it into a SOAP header, all we need to be able to do is get that header into that message. So whatever stack you're using, if you can get in at that level, you can have a non-WCF client interact with this. The other requirement there would be that we were using one of our interoperable bindings, such as the WS star ones. Let's go ahead and check out a demo of this. So we have a very simple workflow that has two receive activities. We've gotten twice as complex as the first demo. And what we want to show here is how we can use that context to keep talking to the same instance of the workflow. We're going to know they're a little different because the first code activity is going to return something that says first time. The second code activity is going to return something that says second time. So let's go ahead and look at the code for the client here. And this is an example of a non-workflow client talking to a workflow service. All we're doing is creating a new proxy. We're going to use the NetTCP context binding. And then I'm going to output the context information while we walk through this. And I'm going to make two calls. I'm going to say hello, and I'm going to send in a second message. So if we look at what's going to happen here, we've returned first time and second time. That's a good indication that we've interacted with the same workflow instance. If we flip over and look at what the host is doing, we are interacting with the same workflow instance ID. And that's the same ID that's being output by the context. Let's look at that a little differently now. Let's go ahead and create our client like we did last time. But once we receive that response back, we're going to throw that client away. We're going to create a new client. When we create the new client, this has no knowledge of the context. So we're not going to be able to deliver the second message to the same workflow instance. And so you'll see what happened. We've returned both times the message first time. If we go and look at what's happening on the service side, we have two different workflow instance IDs. Why does this happen? Because these messages both have come in without context. So the context channel says we need to create a new instance of the workflow. Finally, we're going to do that, but then we're going to explicitly set the context. So we're going to head and create a new proxy, but we're going to grab that context manager and then explicitly set the context to the one that was returned from the first call. This is going to allow us to, again, communicate to the same workflow instance. And not surprisingly, we see first time and we see second time. We're again interacting with the same workflow instance. Once we have the idea of being able to talk continually to you, the next step most people will want to make is that they'd like to enable duplex communication. So this is not just me talking to you and saying, hey, what's going on, and getting a response back. It's at some point you're sending a request to me. You're sending a message to me. So now this is a lot more similar to the two of us talking on the phone. I'm not just making a request of the bank system, the IVR system for my bank. We're having a conversation. And again, this is something like context that we can't rely on the transport level in order to do this. Because if you're familiar with WCF, you may be familiar with some of the duplex capabilities that we have there. But those, again, are limited to the lifetime of that underlying transport channel, which doesn't make sense. I may go ask you to provide me a bid for shipping, and in a week, you're going to get back to me. We're not going to hold a connection open that long. You're going to reboot a couple of times. I'm going to reboot a couple of times. We need to kind of lift that up to the application level. And so the way that we're going to model this is there's going to be two contracts. There's going to be the contract that I'm using to talk to you and the contract that you're using to talk to me. And then the first time that I talk to you, I'm going to have to explicitly provide you with a way to get back to me. So think about this. So you know where I live. You know what the return address is. I'm going to provide a bit of information, the apartment ID, so that you can deliver it directly to me, so that you can call back to me. Way to visualize this in a diagram, we're going to have two workflows again. The workflow on the left is going to be the client. The first time that we call to the service, we're going to initiate that workflow, and we're going to explicitly provide, as part of the message, a workflow instance ID. This is going to be how you're going to talk back to me. In the diagram, it's denoted client ID. Now, our process is going to continue. We're going to continue to add items to a cart. We're going to continue interacting with the service. At some point, we're going to switch roles, and I'm going to wait for you to send me a message. Maybe I'm done telling you what the order is and how the customer would like it delivered, and now I'm going to wait for you to tell me that the order has been shipped. And so we switch roles. And whenever that service is ready to send a message back to me, it's going to explicitly apply that client ID that I sent him the first time. And that's going to be how we get the message back. So let's go ahead and see a demo of that. So here we model this as we're going to submit an order. This is going to establish the order header record, if you will. And then we're going to loop around while we're either adding an item to the order or we're told to complete the order. And then we're going to do some work. We're going to wait for about 7 seconds, and then we're going to notify our caller that the order has been delivered. And you'll see here, we're going to use a send shape. Let's look behind the scenes, what's going on. So on this submit order, if we were to go and look at the operation, you'll see that we're actually passing in context as one of the parameters. Inside this code activity, we're going to take that context and we're going to apply it to that send activity. You'll see here that's what I'm doing. I'm receiving that context, and then I'm saying to that send activity, I want you to use this context whenever you're going to communicate back. Now, we have a workflow on the left side of the equation that's calling this. This is just a normal sequential workflow. It's going to say I want to submit an order, I'd like to add an item, and then I'm going to complete the order. What happens now, this is the part where we switch. And in order to do this switch, we have to be a little more clever. Now, normally we can just, when we want to spin up a workflow, we just spin up a workflow runtime, say create instance and go. In this workflow where I know I'm going to switch around and be waiting to receive messages, I'm going to have to spin that workflow instance up inside of a workflow service host. So I'm going to take that workflow service host, I'm going to grab the workflow runtime, and this code here is a little bit tricky. In the earlier betas, it used to be you could go workflow service host .workflow runtime and get it. Now you have to go through descriptions and ask for behaviors and find the workflow runtime behavior, and then you can get the workflow runtime. But once we get that back, we can do all of the usual things that we're used to doing with a WF runtime. So we can go ahead and hook into the events of a workflow being completed or terminated abnormally, and then we're going to start our workflow instance. And that workflow is going to send those messages, and then it's going to flip around and it's going to wait for a message to come back. So we're going to build this. We're going to spin up the two different console windows. So we've hosted the one. I lied, there's only one console window. We've hosted the workflow in the Cassini-like host, inside, so the self-host option that we have. And then we have our console app, which is where I'm going to spin up that other workflow service host and then spin up that workflow runtime. And so we're going to receive that token. We're going to send it to the server. Server is going to do some work. We're continuing to add items into the cart right now. And now we flipped around and we're waiting. And I'm sitting and waiting for the server to send back to me what is the shipping cost. And the server generates a random number and shoots me back that it's going to be 286. Now my workflow can complete. So once we have the idea of duplex messaging, this is where it starts to get interesting. And this is going to be where I have a talk tomorrow at 10:45, I believe, where I'm going to be talking about context and talking about application patterns that we can do to kind of build up some really interesting scenarios, and want to give a little bit of a flavor of that. So once we have the ability for me to talk to you and then at some point you to talk back to me, we get the ability to start doing long-running work via messaging so that I can send you a message, you're going to go do something at some period in the future. That can be in 30 seconds, 5 minutes, 5 days, 5 weeks. At some point in time, you're going to send that message back to me. Now, we wouldn't want to use a traditional send activity that just calls out to the service and waits for a response to come back. We want to split those into two separate activities. And we model that with a send and a receive. This is applicable in scenarios where you control that service. So you can say to the service, when you're done, send a message back to this workflow. So let's go ahead and look at a couple of different workflows here. I'm going to walk through what the different experiences we get are. First, we're going to call take a while. Take a while is a very useful service. It's going to block for 3 seconds and then return. So I'm going to call 3 of those in parallel first. And what's going to happen is that these are going to occur. This is not going to take 3 seconds. This is going to take 9 seconds because we're going to execute each one of these sequentially. Because each one of our send activities is going to block while we make this call. So we're going to call the first one. And you can see here that these are starting at about 3-second intervals. And that took 9 seconds. Okay, but we'd like to have a little more control over that. So what we're going to do now, we're going to call a service operation that we call one-way take a while, which if we look at the contract, you'll see is marked as is one-way equal to true. What this tells WCF to do is once the message gets there, once we know the bits have gone across, I'm going to return back to the caller. So this is going to be really fast. And what you're actually going to see, that took 0 seconds. So I've arranged 3 calls. If we go and look at the workflow again, I've arranged 3 one-way calls here. Each one of these completes almost instantaneously. What's the problem with this? I have no idea what just happened. I have no way to find anything out from those services that I called. Now, if I don't care, if I just want to fire and forget, we can go ahead and go with this pattern. But in reality, a lot of times, we're going to want to wait and collect the responses back. So in the final sample, what we're going to do, we're going to use this pattern of a send and then a receive. And we're going to do 5 of these at the same time. So we're going to call out to that service 5 times. Each of these is a one-way message, so it's going to be very, very quick in getting the message there. And so this is going to take about 3 seconds to complete. We go over here, we see we're actually outputting a little bit more stuff, and it took about 5 seconds. There's some overhead associated with it being a demo machine. Now, the interesting thing to see here, there's a couple of interesting things. Now I've been able to effectively parallelize my work so that I can execute as many of these as I'd like in parallel. But now we get to that reason why a context token is a dictionary. Because what am I doing here? Well, I'm actually waiting in 5 spots on the same operation and message type. So I'm not just waiting for a message of a given type to be delivered to a workflow instance. If I just know the workflow instance, I'm only going to be able to get to the workflow, and then I'm going to say, I've got 5 of these activities. Which one does it belong to? So in this case, context has to get a little smarter. Our context can't just contain the workflow instance ID. It has to contain a conversation ID. And the way that we initialize a conversation ID is by specifying on a receive activity that it has a different owner activity. So by telling it has an owner activity that is not the base workflow, we're going to construct our context token relative to that parent activity. And when we do that, now we know there's more than one of us waiting. So we're going to have to be a little more clever. We're going to have a workflow instance ID and a conversation ID. And so if you were to look and catch here, we're actually seeing that the context token contains the instance ID and the conversation ID. We follow the same pattern that we were talking about with that duplex communication. I have to explicitly provide to you not only the workflow instance ID, but the conversation ID as well. And that's going to enable some pretty rich application protocols. If you start thinking about scenarios where you want to send out a request for bid, and I need to listen for that same message to be coming back to me in a few different places. And so, in summary, as we wrap this talk up, workflow services provide a really natural way to model services. It allows us to take all of the goodness that lives inside the service-oriented world, that lives inside this idea of services, and rapidly consume those from a workflow. And if you think about workflow being this model of composition that allows us to compose bits and pieces, we can start to compose services out of other services and start to build up some really rich functionality pretty easily. The second takeaway is this. Once we understand what's going on kind of at the 100 level, we have to start thinking about context. And the reason we want to think about context is that it's going to open up some richer scenarios for us. You can go ahead and check out my blog. I'm going to have all the samples posted up there. You can also send me an email at mwinkle@microsoft.com. If you'd like to get in touch with Justin, I can also forward your information. We have a Q&A slide, but first, before we do Q&A, I would like to remind you to please fill out your evaluation forms. Justin and I take them very seriously. Our boss does too. But we really do appreciate it. If there's something that we could have done better, please let us know. But if you put all 9s down, you triple your chance to win the phone. It's a little secret. Thank you very much, and let's go ahead and open up for questions. questions. Good. If you can head over to the microphone, that'll be good because they're recording these.
Is there a reason why there's not an MSMQ binding?
I'm sorry?
Is there a reason why there's not an MSMQ binding?
Yeah, so the reason that there's not an MSMQ binding is that we have to have, in order to be able to send that context token back, we have to have a channel that is not completely one-way and queued like MSMQ. So we can certainly use MSMQ to go ahead and initiate our workflow, but the catch is that we have no way to flow the context back. The other thing is that inside Windows Workflow Foundation, we don't have the ability to flow a transaction in. And so we could get in a scenario where with a one-way communication, such as MSMQ, that we take the message off the queue, we deliver it to the workflow, and something bad happens, but we can't wrap that in a transaction. So if we could wrap it all in a transaction, then we'd be fine. We'd go ahead and deliver that message, and if something went horribly wrong, the message would still be on the queue. But since we can't flow in a transaction, we can't do that. That is one of the very high priority items that we're looking at in Oslo, is the ability to flow in transactions as well as enable queued support for that. There's also some things you can do at the channel layer if you want to use MSMQ with this in order to attach the context, and follow up with me offline, and we can certainly dive into that. Other questions? Yes.
In the workflow to expose it as a service for input parameters or for return values, do we have to use the workflow properties or there is some other mechanism?
So the question is for a receive activity with the various input parameters and the output, how do I have to use workflow properties and binding? So the way those are going to be represented are as properties on that activity that we can then take and bind to something. So we can't get away from using them as properties. We don't necessarily have to do data binding to an explicit parameter. We could bind to another property on a different activity in the tree. We could certainly do that. Other questions? Yes?
Can I change implementation or change the workflow?
Okay. Yeah, so the question is, I've got these long-running instances. There's going to be something sitting for a month, and gasp, my business process changes. How do I handle that? And that leads to a great 90-minute talk I give on versioning that I won't be giving here, but if you're really interested, come find me and we can sit down over beers or something. But the short answer is yes. There is an API called Dynamic Update. Dynamic Update allows me to point at a single running instance of a workflow and change that. So even for a workflow that's in flight with all of its stuff persisted, I can still go to it and change it. We have some other support for versioning, so we can do side-by-side. So if you have the model where you just want new instances of the process to have the new definition, that's the easy case. If you want to change all of the instances, then we can drop down to Dynamic Update. And we've got samples of that in the SDK. Yes?
The workflow in SharePoint services, will it have all these features?
So the question is, will workflow in Windows SharePoint services have all of these features? The answer is sort of. And the reason it's sort of is because the SharePoint host is locked down and you can't add services to it. So when I say services, I mean workflow runtime services. So we're not going to be able to take advantage of the capability from within SharePoint. You could probably use the send activity to consume a service, but you won't be able to, in the short term, expose a SharePoint workflow with a service endpoint. They're definitely looking at that in the Office team for the next version of SharePoint Server. Trying to figure out how to do that in a nice, safe way. Other questions? So the question is, can you load balance it? And the answer is certainly. So what happens, we persist out to the persistence store. A request comes into a different server on the farm. It's got a context token associated with it. That server is going to say, hey, I need to grab this workflow instance ID, and we're going to grab that from the store. The persistence service is scale out aware. So we're going to do some logical locking so that we don't pull two instances, pull up the same instance on two hosts at the same time, because that would be bad. So we do have some support there. Where it gets a little trickier, and I will defer to Justin, would be the load balancing on the WCF side, if you have requirements to route to a specific instance of the server. And that's a conversation we could certainly have if you're interested in.
Yeah, that gets interesting when you're, I'm not sure if this is on, when you start considering some of the WS star support. You know, if you're in the middle of a WS secure conversation, how will that flow across servers, that sort of thing. But in the base functionality, yeah, absolutely, it's there.
Yes?
An application has a workflow, then we have two options. One is I develop a service and augment that service with the workflow. The other option is I expose the workflow as a service itself. Are there any guidance or some guidelines on which option we should prefer or what way we should go?
What was the first option?
First option is I expose a WCF service and it uses the workflow internally. So it just, the service gets augmented by the workflow.
Okay.
And the other option is I expose the workflow itself as a service.
I think that's the same thing. So the question is, I can either implement my service as a workflow, or I can expose my workflow as a service? No? Okay.
Okay, service uses the workflow.
Uses a workflow.
Another option is the built-in support of the
Okay. Okay. So the way I understand the question, I would always argue in favor of using this. One, because I'm the workflow evangelist and that's my job. But also because all you're doing in that other case where your service uses the workflow, now you're maintaining kind of an additional layer of indirection that's not buying you a whole lot. That's kind of what we had to do in .NET Framework 3.0. And the problem with that is not so much, one is that you're adding that layer of indirection, but there's a different messaging paradigm to a workflow. So the way workflows in .NET 3.0 work are that they listen for events. So now you're kind of mixing your metaphors. You have a service, you're receiving a message, but then you need to do some work and raise an event. And that, to me, seems kind of clunky. I'd much rather just focus on messages and services.
And kind of to that point, we've, if you take either approach, we've written several applications internally and work with several customers on this. It's nice that, you know, when you're making that kind of decision, you can kind of, sometimes there's fear, like, am I going down the wrong path here? We've switched, you know, at different points down the path, and it's a pretty open model. Because, you know, I've built services using just WCF, and then I said, all right, I want to insert WF as a backing store now, and I want to use this workflow services bit there, without even thinking about workflow to begin with, right? It's maybe a new requirement that appears, and I haven't had to change the contract at all. Likewise, we've approached it from the other direction where we've got a workflow. Oh, this is really cool. Let's expose it as a service, and we don't really need to change the workflow. You just add a receive activity as a create create activity, right? So it's a really nice model there that appears to hold up quite well under those kind of changing requirements.
Got time probably for one more question? Going? Yes.
Is there a performance penalty by going to instantiate a new workflow runtime each time message arrives?
Okay, so the question is there a performance overhead? And one, we're not going to create a new workflow runtime every message that arrives. We're going to have a single workflow runtime per workflow service host that's going to be shared among all of them. The workflow runtime is thread safe. It works best in a singleton pattern. So there's only going to be one of them. So we don't have to worry about overhead there. There is some overhead when we create an instance of a workflow, but that's because we're enabling some functionality that we didn't have before. So we do have a little bit more overhead than just expanding a type if we're pulling it out of XML, out of a database and instantiating it as XML. But just creating the workflow itself is just instantiating a type. There's some validation and activity lifecycle stuff that occurs, but the performance overhead is, we've tried to keep it very small.
Anytime you add durability to, you know, this kind of capability when you go away from a totally volatile system, there is a perf hit. So this doesn't help your performance, but it gives you that extra feature. And that exact perf hit depends on exactly your object, right? I mean, so it's not a single number that we can give you. As with any perf, we encourage you to test on your own, given your own parameters there, right? Given your own environment and given your own, perception of a workflow or work demands on that server.
All right.
All right, guys, thank you very much. Have a great rest of the conference.